I usually start my presentations introducing myself a little bit. However, we've already gone through that. The only bit that I would like to add is that besides being a programmer and a public speaker and author, etc., I like to consider myself a bit of an adventurer too. So last summer, I had the chance, for instance, to have my first flying lesson. First and so far only, but I do hope that I repeat the experience. I have to say it was incredible. It was exhilarating and terrifying at the same time. You know, the views are magnificent, but then when you think of there is absolutely nothing around me, it does get a bit of a, you need to keep your nerves with you because it can get a bit terrifying. Fortunately, you do have a co-pilot, so you know that if you do anything wrong, then he's going to fix it. If you do have the chance to try it, please do, because it's seriously a fantastic experience. So anyway, let's get to today's talk. But before getting into the topic, I'd like to do a bit of a disclaimer. I'd like to mention what this talk is not about. And the reason for me to say this is because, well, when you talk about cloud environments and how to set them up and how to manage them, etc., then many people think that you're going to be doing a tutorial on Docker, or Kubernetes, or Fargate, or Terraform, or Helm charts, or Azure, or any of these magnificent tools that are out there today. So that's not what I'm going to do today. If you do want a tutorial on these things, just go to Google, search, you will find loads of them, very good ones, from people who know much more about this than me. So that's not what I'm going to talk about today. What I'm going to talk about instead is how the growth of this kind of tool and the capability that it has given us to create new environments very easily, very rapidly, very smoothly, has come with its own baggage. You know, these tools, they are great, but they're not perfect, and they come with their own problems. So what I'd like to mention today is the operational, reputational, function, and economic cost of running multiple test environments, thanks to this ability that we now have of creating new environments very easily and very quickly. More specifically, I'm going to talk about three main problems and three ways in which we can address these problems. So first of all, I'm going to talk about filter management, for which I will introduce the concept of universal filter flags. Then I want to talk about test management. I'm going to talk about meta automation here. And then finally, I'm going to talk about environment proliferation. This is probably going to be the biggest, and I dare say most controversial topic, perhaps. And against that proliferation, I'm going to be arguing for environment rationalization. So I'm going to be tackling that proliferation that we have, that multiplication of environments, and asking whether we actually need them. So let's try to, I'm going to try to guess what your current situation is. Obviously, I cannot talk to you. I cannot ask you feedback. This is one of the things that I could maybe do if we were doing a face-to-face presentation, but it's not the right moment for that. So I'm going to try to guess. Now, if you're here talking about this, I'm going to guess you probably have a microservices environment with a number of services that talk to each other, something like this. It might be bigger, it might be smaller, there might be more arrows, more things talking to each other. Of course, these bubbles could represent anything. They could represent services, or they could represent queues or databases or anything that you like. The point is, you have many different things that talk to each other, right? In here, there are, I think, about 13 of them. In a typical microservices environment, I would say you probably have more. 20, 30, 50 are not unheard of numbers of services in a microservice environment. So let's just go for this as a representative example of what you probably have. However, this is not really the full picture, because this is just one instance of your system, right? Maybe the production instance, but in reality, you have multiple copies of your system, right? You may have production, but then you also have some staging environment and some integration environment and some performance testing environment. So you actually have multiple copies of the same thing. And it's very important to keep this in mind, because the ease of creating and managing multiple copies of our system might make it easy to forget what we actually have. We don't have that simple picture of things talking to each other. We have that same picture repeated, overlaid on top of each other. We have multiple of them. This is the situation that I want to talk about today. So with that in mind, let's go to the first problem, filter management. So you have a system, and yeah, let's say that as part of the system, you're developing a new piece of functionality. Now, you may decide to put that new piece of functionality straight to production as soon as it is available, or maybe you want to hide it. You want to keep it tucked away until you are done with it, or until you have, built some confidence or some marketing communications, whatever the reason. So you want to maybe develop it, but not make it available yet. Well, that's easy. You just create a filter flag, right? Or filter toggle, you may call them as well. Now, in an ideal situation, all that new functionality that you're creating will be tucked away in a single service, right? So you have this filter flag probably in the form of a config item. And then in that particular service, what you do is in your code, you check the value of the filter flag. If it's off, then you go down one particular route of code. If it's on, then you go down a different particular route of code. That way, you can develop the new thing, you can test the new thing, but you can decide when you make that new thing available to the public. This is usually what we call making a distinction between deployment and releases, right? So a deployment would be whenever you have a new binary and you make that new binary available in production, right? You create that copy, you put it there. And a release would be whenever you make a new piece of functionality available to the user. Those two things can be different, and we manage that with a filter flag. Right, so this is great. However, the real situation is not always like this. We would like our new features, our new functionality to be tucked away, hidden in a particular service, in one specific service. But sometimes that actually spread through several services. And this is not necessarily bad design. These days people talk about domain-driven design and this or that, and how your different services should mimic the functionality of your business. So then whenever you're developing something new, it should ideally go all the changes to the same one service. But reality sometimes catches up with us and things are unexpected. And what we thought was a good design 2 years ago, today is not so, I'm not going to say it's not so good, but it's not as clean or as clear cut as it was in the past, which means that sometimes we're developing a new piece of functionality and we want to hide it in a filter flag, but that filter flag is not going to be present in a single service. It's going to be replicated in several of them. That means that whenever we want to enable or disable that functionality, we need to be very careful to go to all those different services where the filter flag is present and make sure that the value of the filter flag is synchronized in all of them. Because if it isn't, then the system is going to behave in unexpected or wrong ways. To add to the complexity, sometimes it's not just about remembering to activate or deactivate all the filter flags. You also have to do it in a particular order, because if you don't, then again, your system may behave in unexpected ways. And that goes for both activating and deactivating. Maybe you activate in the right order, you realize something is not quite right, so you want to deactivate. You need to make sure you have a rollback procedure in which you know in which order you need to deactivate things for it to work in the way that you want it to work. So filter flags, you have all that complexity, even when you are dealing with just one environment, but then you have to remember that you have to do all this management of the multiple copies of the filter flags in all your different environments. And here in this picture, I'm only talking about one particular feature that you might be developing. But if you have a moderately large development team, then you might be developing more than one feature at the same time, which means you may have multiple feature toggles spread across different services, duplicated in different environments. So for instance, if let's say you're developing 3 different features, each of them impacts an average of 3 different services, which means those 3 different services need to have a feature flag for that new feature. And then you have 4 different environments, production plus 3 test environments. That means you have 36 pieces of configuration that you need to manage. And when you have that many pieces of configuration that you need to manage in a dynamic environment where you're making changes all the time, eventually you're going to make a mistake. That's just inevitable. So how do you avoid that? Well, the idea is avoid the duplication. This is a strategy that we've been following in software development for very long. Whenever you have duplication, try to consolidate that duplication and put things in a single place. So here's what I'm going to be talking about: universal feature flags. Instead of having multiple copies of that feature flag spread across services, have one single place where you have the feature flag, and all the services that need to know about the value of the feature flag talk to that one single point. I'm also calling this feature flag as a service, or FAS. I say it like that with a double F to differentiate from FAS with one single F, which is usually what people call a function as a service. So this would be a feature flag as a service. So how does this work? Well, instead of having your feature flag replicated as a new config item in all the different services that are affected or impacted by this new feature, what you do is you create a new service that is the feature flag service, and then you make all the other services talk to that service to ask the service, hey, what's the value of the feature flag? Which particular branch of code should I follow? Now, when you want to enable the functionality, there is only one place where you have to go to make the switch, and everything else will just talk to that one thing and adapt automatically. And again, if you want to disable, there's only one single place where you have to disable that particular toggle, and everything else will just go to that service to ask what the current value should be. There are some additional benefits to this. On one side, because all your feature management is concentrated in a single service, you could easily expose an endpoint that gives you a report on the current status of all the feature toggles. So you can easily just make a call to the service and say, hey, what's the status of functionality in, let's say, the integration environment or in the staging environment, and you just get a quick report. Moreover, you can probably script this. So in a quick go, you can just ping all your different environments. You can ping the feature flag as a service in all the different environments, produce a report, and you can even compare and realize where you have differences. And you can present that to stakeholders, to whoever needs to know this information. When someone asks, hey, did we enable this or not? There's one single point where you need to ask that question. Now, if the idea of having a particular service for storing feature flags sounds odd to you, that's okay. It's not a common thing, I would say. If you'd like to see an example of how this actually works, well, a few years ago, I co-wrote a book with Daniel Bryant. In this book, we actually talk about feature flags. There's a whole section dedicated to feature flags and configuration management. To demonstrate the content of the book, we created a public GitHub repository in which we present an example of a microservices environment with different services talking to each other. And within them, one of the services is the feature flag service. So if you'd like to see an example of how this can work in practice, you can take a look at this GitHub repository. You don't actually need the book to take a look at the repo. It might help just because it provides context and explains why things are done in a particular way. But you're more than free to just get a copy of the repository, take a look at the code, and see how it goes. If you're still reluctant to create a service just for managing feature flags, well, you don't need to. You can use some existing commercial offering. For instance, LaunchDarkly. This is pretty much a feature flag as a service, but provided by a third party. The good thing about it is that it works with pretty much any form of programming that you have these days. It can work with any programming language. It can work with web services, with iOS applications, Android applications, pretty much anything that you develop and that has features that you want to be able to manage and toggle on and off. You can control with launch directly. It also creates some very nice reports that you can provide to your stakeholders if you need to. So really, it's an option that it is worth considering. Right, so that's the first of the problems, feature management. Now we're going to go for another one that is a bit of an extension to feature management, which is test management. Now, when you have your different environments, typically you will create tests that assess your functionality, and you don't want to rewrite your test for every different environment. You will write one particular test, and then you run that test in all your different test environments. However, if your environments have toggles, that means that the expected behavior in your different environments might not be the same, which means that the expected tests for each of your environments will not be the same. So for instance, you may have a set of tests that check behavior for the cases when the feature flag is on, and then a different set of tests, a different set of assertions that assess or that exercise the behavior of your code when the feature flag is off. So typically in your higher environments, the ones that are maybe closer to production, you want to run the expectations for when the feature flag is off. But in your lower environments, the ones that are closer to the development process or to the developers, you want to do the opposite. You want to test, you want to exercise the tests that assess what the behavior of your system is when the feature flag is on. Now, there are many different ways to manage this, but what I've seen is that typically what people do is they will treat this as just a different configuration item. So whenever they enable a feature in an environment, whenever they toggle those feature flags, then they go to the test configuration and they also change the test configuration so as to tell it, do not run these tests, run these other tests instead. Or sometimes they actually literally have copies of the tests in different environments, or they will comment out or include in tests. You know, it's a very manual endeavor. Effectively, you know that problem that we saw before in which our feature toggle had to be replicated in different services because it impacted different services. Well, it's like you have that feature toggle replicated in yet another place. It's just that in this case, it's not a service, it's your test configuration. So what we're going to do is we're going to extend the strategy that we had before. And what we're going to do is we're going to consult the value of the feature flag in that feature flag service. And then automatically, based on the value of that flag, then I'm going to automatically select which tests I'm running and which tests I'm ignoring. This is why I call this part meta automation. Because essentially what we're doing is we're managing our tests, our automated tests in an automated way. So we are automatically manage our automation. So like I said, the way this looks is you test it before it runs. It will make a call to your feature flag service. It will get the values of the feature flags. Maybe with that report that we talked about, it's just say, hey, give me the current configuration in this environment. And it will say, feature A is on, feature B is on, feature C is off. And then based on that, the test suite will automatically change the configuration of the test before running, and then it will run the test. And you will know that it runs exactly the test that it needs to run, and it ignores the test that it doesn't need to run. Now, the mechanics of actually doing this will depend a bit on the actual technology that you're using and your testing framework. But from what I have seen, all of them have something that you can use. So first of all, you can do a quick call, something like that, to the feature flag service and get the values of the feature flags. And then you can use that to introduce parameters to your test run. So for instance, if you run a .NET shop and you run your tests with NUnit, you can use categories. So you can include this category annotation in before your test. in which you say, this is a test for the filter flag being on, or this is a test for the filter flag being off. And then prior to running, you can tell your end unit framework, run the tests that have this category. And deciding which category to run, again, is done by calling the filter flag service, finding out the value of the toggle, and then that way you establish the category that needs to run, and then automatically you will run the test that you need, ignore the ones that you don't. JUnit 5 or JUnit Jupyter, if you run a Java shop, it also has something similar to categories, but in this case, I think it's a bit more intuitive to use enable if environment variable. So this pretty much does what it says in the tin. You indicate the name of an environment variable, you indicate the value of that environment variable, and then if those conditions apply or match, then you will enable the test. You can also apply the opposite logic if you prefer. There is a disable if environment variable. So what you can do is disable test if an environment variable has a particular value. And then just to add a third example, if you run a Scala shop, then there is this particular function called assume, and you can pass in a condition. If the condition is satisfied, then the test will run. If the condition is not satisfied, then the test will not run, it will be ignored. And that condition, again, it could be anything. It could be an environment variable, a parameter passed into the virtual machine. It could be whatever you want. So that's two of them. Now we're going to go for the bigger one, the environment proliferation, all these multiplication of environments that you have and how we can tackle it. So remember your situation. You have these multiple copies, these multiple instances of your environment. And here's the thing. How many of them do you actually have and why? So for instance, you probably have, like I said before, a production environment. I'm sure you do. You probably have a staging environment. Staging in this sense, meaning an environment typically used for regression testing. The configuration of the staging environment is exactly the same as the one in production environment. Here, I'm talking about filter flags, filter toggles. I'm not talking about things like database connections and things like that. That will obviously be different. But yeah, here you have a second environment, staging, which is just an environment, like I said, that you use for regression testing and that has the same configuration as production. Now, you may also have what I call a full integration environment. This is some place where you are testing new functionality. And in here, you have all your services, all your elements, queues, databases, wherever you may have, plus all those things that you depend on, like, for instance, third-party systems that you talk to, right? That will be the full integration environment. This will be a place where you can test your new functionality in a way that most closely mimics what it will be in production. Now, the problem with full integration environments is that it includes third-party components. You don't control those. So whenever there is a problem with those, you may have broken tests that don't really depend on you, and you don't really have the capability to fix them. So typically what you do to try to differentiate between problems in your system and problems in the overall solution is you also have what I call an owned integration environment. And owned means pretty much that. It's like a full integration environment, but focusing only on the bits that you own, the bits that you control, right? So in this case, the third-party elements would be excluded. You also may have a performance testing environment, right? So whenever you want to see if your system can cope with a particular level of traffic or something like that, you typically might do that in a different environment, the performance testing environment. So that is a fifth environment that you may have. And then for whatever the reason, for whatever the need in your organization, you may have many other environments. But in this case, I'm going to focus on this particular 5. Now, what's the problem of having multiple environments? Well, on one side, you need to manage them, and that adds to the operational cost. You need to have people doing things. And then, of course, you need to support them, because the more things you have, the more things that can go wrong. And that means the more people that you need just to keep things running, just to keep the lights on. But on top of that, here's the thing. You have to pay for it, right? There is an economic cost to all of this, right? You may think it's very easy to forget about the cost of running your environments just because it's so easy to press a button and have it. But at the end of the day, you're going to get a bill from your cloud provider. Or if you have some internal provisioning system, okay, you may not get an actual bill, but still, to provide teams with the capability to create environments on demand, somebody has to create or maintain a data center or a set of virtual machines or something that just provides all this infrastructure for you to carry on creating environments on demand. And this is where it becomes a double-edged sword, right? Because on one side, the tools that we have nowadays, Terraform, Kubernetes, Azure, Fargate, whatever you name it, it makes it so easy. It makes it so straightforward, so smooth to create new environments that you might forget about everything that is happening underneath. And when you're in a situation where you forget about everything that is happening underneath, you will forget about everything that is happening underneath. And then you will get to a point where you are spending a particular amount of money and you're not quite sure why. You're not quite sure where your money is going. This has got to a point where people are actually making a career out of coming to you, taking a look at your environment, taking a look at your cloud configuration, and explaining to you your bill. One of these people, slight digression, is Corey Quinn. He basically makes a living on analyzing the AWS configuration of people and telling them this is where your money is going. He's a very knowledgeable guy. He has a blog, he has a podcast. He's a trove of information. And also he is a very, very funny guy. So I do advise that you follow him, first, because he's funny. And second, because it will be quite an eye opener about everything that might happen in your cloud environment and you may not realize, and everything that you're paying for. So it's important to keep an eye on the cost. Okay, you may say, I don't care about cost. I have budget, I have massive investment, so I just pay for things and go for it. Okay, then don't worry about cost. Worry about everything else. Worry about operations. Worry about distractions. Worry about all the time that you're spending keeping these things on that you could be spending developing features. After all, we live in the age of lean, right? These days it's all about make sure that you only keep exactly what you need and nothing else. It's all about identifying what you can live without, getting rid of it so you can focus on the things that you actually need and that actually bring value to your company. So then, because of all these reasons, for whatever the particular motivation that you may have, whether it is cost, whether it is operations, whether it is you just cannot have enough DevOps engineers, whatever the reason, I'm going to suggest that you take a very hard look of all the environments that you run and decide whether you actually need them or not. And if you struggle to do that, then what I'm going to do now is I'm going to go through all the environments that I presented. I'm going to give you some reasons for which you could actually get rid of it and be happy without it. So let's start the journey. First of all, oh yeah, of course. This is what I call the environment rationalization or fat trimming, right? So this is running lean means getting rid of the fat. So what we're going to do is go one by one, like I said, through all the environments and check whether we actually need them or not. First of all, production. Do we need a production environment? Well, yes, you do need a production environment. If you don't have production, then you might as well close the shop and go home, right? So we need to keep that one. That's it. Second, what about the staging environment? Do you need a staging environment? Like we said before, the point of staging is to have an environment where we can replicate the configuration that we have in production, right? So if in production we have this particular set of toggles on and off, then we replicate that in staging to be able to run regression tests, right? So the whole reason for staging to exist is the fact that we have feature flags, is the fact that it's somewhere we need to have a configuration that is exactly the same as production so as to be able to do regression testing and make sure that we're not breaking anything. Well, what if we didn't have any filter flags? What if we didn't have any toggles? Then there would be no point for staging, because there wouldn't be a difference in configuration across environments. There wouldn't be a place where I need to test here this particular branch of behavior, but here this different branch of behavior. The branches of behavior would be the same in all environments. And if that is the case, then you don't need a specific environment to mimic production. Now, this might sound a crazy idea, but it's not really that much, because if you think about feature toggles, we've had them for quite a while. Here's a blog post by Martin Fowler from 12 years ago, in which he starts talking about filter flaggers or filter flags. And even back then, he was saying, do not use filter flags unless you actually have to. Why? Because the idea is, if you're running an agile shop and you want to get feedback quickly to know how your things are working, you want to put this into production as quickly as possible. Filter flags, at the end of the day, is just another way of building stock. It's just accumulating functionality that nobody is using and that you don't know how people are going to respond. And you just keep accumulating it and then switching it on at the same time, hoping that people will like it. So if you can afford this, a better way of developing would be, instead of having filter flags, get that feature and break it down into smaller bits, so small that you can actually afford to deploy them to production straight away without the need of a filter flag. Just put very little changes of functionality available to the users straight away. If you do that, first, you get faster feedback. You get to see how people respond sooner, but also you remove all the operational complexity of having to manage filter flags. And then finally, you don't need a staging environment. So that's one good reason to at least try to analyze your situation and ask yourself, do I actually need filter flags? Could I change my development process so I do everything in very small increments and I don't need filter flags? So that's the first point. If you can manage to live without filter flags, then you do not need a staging environment. And that's one environment that it goes and that you don't have to pay for anymore. How about the full integration environment? Okay, the thing with full integration is very closely related to own integration, right? We said before, mainly the difference is the third-party component. So if this is an example of your system, then this particular boundary would represent your full integration environment. This particular boundary would represent your own integration environment. Now, the real picture wouldn't be as nice as this. It wouldn't be one system with two different boundaries. It will be two different systems. You would have this replicated in two different places, just one of them including everything, the third parties, and the other one having some kind of substitute for the third parties, so you don't have to call them, right? But you would actually have two different environments. Now, the problem here is that you're operating at nested levels of testing, right? You have one higher level, which is the full integration, and one lower level, that is the owned integration environment. If instead of working on nested level of tests, you worked on chained level of tests like this, then you wouldn't need the functional, the full integration environment. You could afford to stay just with the owned integration environment, and then an additional bit that just checks the connection with a third party, that just checks that that interaction is going as expected. This would have a number of benefits. First of all, if your third parties are broken or unavailable or anything like that, it doesn't affect your own integration environment. It would only affect the particular bit of communication. And you will know very quickly that the problem is either in the communication or in the third party itself. So first of all, by reducing the scope of your test, you can isolate faults much more quickly. Second advantage, whenever something fails in your own integration environment, you know straight away it's something that you have caused. It's not a third party, it's not someone else. So again, by reducing the scope of your test, you can identify issues much more quickly. And then the third advantage, of course, you get rid of the full integration environment. You don't need it. Now, this connection here the integration with a third party, there are many ways you can play this. There are many different tools out there. This is just a sample of tools. It's all about having what they call test doubles or mocks or stubs or whatever you want to call it. There are many different names. There are arguments about what a mock is and what a stub is and what a test double is. I'm not going to get into that. But essentially, the idea is you can, for your own integration environment, have one of these tools that replaces or that mimics the external party, and then maybe use this very same tool to integrate with the third party and see how it works. Hoverfly is a very good example of that. So basically that one, what it can do is it can first record your actual communication with the third party, therefore acting as a test of that communication. But then it can store the results, it can store the responses that your third party gives you, and then it can act as a mock for your own integration environment. So you wouldn't be talking in your own integration environment to the real thing, but you will be talking to something that has been configured by inspecting and copying the real thing. So it will be quite close to the real thing. Now, I would love to go over these tools because they are fantastic. Unfortunately, that would be beyond the scope of this talk. So what I'm going to do is I'm going to refer to a different presentation that I did a while back with Daniel Bryant, in which we actually go through these and several other testing concerns and isolation boundaries, security, et cetera, et cetera, et cetera. In fact, you will notice if you do see the presentation that some of the some of the last slides that I showed you are borrowed from this presentation because I thought it was actually applicable to the current topic. So anyway, the point is, if you can manage to reconfigure your environment so you work in chained test levels as opposed to nested test levels, then you do not need a full integration environment. And that's another environment that goes out the window, and that's more cost that you are saving. Okay, how about the owned integration environment? Now, we just said we don't need the full integration environment because we have the own integration environment. So surely we need to keep that one, right? Or do we? Now, if you don't have the own integration environment, you pretty much don't have anything left. You don't have any pre-production environments to test. So if you wanted to test something, either you test it locally in your development machine, or you go straight to production. Testing in production is crazy, isn't it? Or is it? If you try to do that, you wouldn't actually be the first people to do it. Skyscanner, if you don't know, Skyscanner is a flight comparison site. You can just search for flights from X to Y, and it will give you a comparison of all the prices of all the different airlines. They do not have any pre-production environments. They do not have any test environment. They just go straight to production. Now, they realized they can afford to do this because they checked how the system behaves. They checked how much risk there was in their changes. And they said, the risk that we have is so little, and our production and our development process is so robust that we can actually afford to push things to production straight away. We do not need the cost of having a pre-production environment. Now, I'm not saying that everyone can afford to do this. There are many scenarios in which you do want to test things before putting into production. I'm going to go for a very extreme one. Let's say you're developing the software that manages the core reactor of a nuclear plant. Please test that before putting that into production. Okay, do not go straight to production with that. But if you're not running any of those things, then you can take an honest look and a hard look at yourself and say, hey, could we actually go straight to production? How many bugs do we actually find in the pre-production environments? And when we do find them, how severe are them? And is the cost of running a pre-production environment justified in this case? What would happen if all those bugs that we found in the pre-production environment, we found them in production directly? How bad would that be? And how does that compare with the constant running cost of having a pre-production environment? That's something that you can definitely do. And you can consider whether you can live without a pre-production environment. even if you say, no, I can't afford to do that, there are things that are too risky, or I'm too afraid, or we're not ready for that kind of thing. Well, maybe you can run some things in production and some things in the pre-production environment, right? You could have a smaller pre-production environment that doesn't include your entire system. It just includes the high-risk items, and everything else you just deploy straight to production. If thinking that you test some things before production and some things production is weird, again, you wouldn't be the first people to do that. Did you ever hear about the Chaos Monkey from Netflix? Now, Netflix became very famous when they introduced what they call the Simian army. There was the Chaos Monkey, the Chaos Gorilla, I think it was, and then the Chaos Kong. These days, they've pretty much retired the army, and the only thing that remains is the Chaos Monkey. This is a little program that the only thing it does is it pretty much causes chaos. So they run this in production constantly, and what the Chaos Monkey does is it will turn off things just randomly. So it will turn off an application here, it will turn off a particular server here, it will kill a Java virtual machine there, just to see what happens. And the idea is, if you have a thing that is constantly attacking you and you are fine, that means you have built a resilient system. So basically, the Chaos Monkey answers the question, what happens to my system when I kill a particular pod or a particular server or a particular service? What happens if I make a database unavailable? That is testing. And if you're doing that in production, then you are testing in production already. So do not be afraid about the sentence testing in production, because it is actually more common than you think. And in fact, if you want to do something like the Chaos Monkey, I don't think there's much value in doing that before production, because the traffic before production is not really representative from what is happening in production. So if you want to really understand what happens when things go down, you need to do this kind of thing in production. So like I said, take a hard look on yourself and ask yourself the question, can I live testing in production? And if the answer is yes, then you do not need their own integration environment. You can just get rid of it. And that's another one where you're saving cost. Finally, I like to talk about the performance environment. Now, performance is a bit of a funny animal, right? Because it is testing, but it's a special kind of testing, isn't it? Many people talk about non-functional requirements as if it was a different type of requirements. Now, there's a big debate that we could have on whether the phrase, even the phrase non-functional requirements or non-functional testing is a good phrase. What does it mean non-functional? Does it mean if my website is slow, it doesn't matter because the functionality is correct? Well, if your website is slow, people are going to leave. So it doesn't matter how correct your functionality is. But that's another point. The point is, why is performance so special? Why do we do it aside? Well, the thing is, in your normal pre-production environment, where you're testing your functionality, you typically have low traffic, right? You have a few testers just poking things here and there. Maybe you have a few automated tests also running in that environment. But how many concurrent users is that going to be? 5, 10, 20 at most, if you have a lot of tests running at the same time? Now, when we talk about performance testing, we don't want to go through, such small numbers. We're going to go big. We want to do like 5,000 users, 10,000 users. Let's see what happens when we really hammer down the service, right? And that's why when we start doing performance testing, it is very often that we start knocking things off, right? We just, we attack our service, we wouldn't prepare for it, and then this thing just runs out of memory, and this thing start having a DDoS attacks, and it just falls over the place. Now, if that is the case, it is kind of understandable that you want to run that in a different environment, right? Because if you have some user, some tester verifying the latest functionality, or maybe even doing a demo to stakeholders, you don't want that to fail because someone else is hammering the system with 5,000 concurrent users, right? So that's why you do it in a different place. Because we're jumping from 5, 10 users to 5, 10,000 users. But we're forgetting something. We do agile development, or we claim to do agile development. And one of the core tenets of agile development is work iteratively. Build your application slowly from the ground up. Just do small additions, small increments. It's all about the small increments, right? You have a little bit of functionality, then you add a little bit more functionality, then a bit more functionality, and you gradually go back like that. You know, we learned a long time ago that doing a lot of functionality and then testing everything together and then deploying everything together, that was a bad approach. That caused so many problems. So we said, no. We need to work in small increments. However, we come to performance testing and we say, yeah, let's go from 5 to 5,000 in one go. Yeah, that's going to work very well. So why do we do it like this for performance? Why is performance different? Because think about it. One of the things that we learned is, in the old days, we would do all the functionality and then all the testing, and then we forget about it. We just assume that it works. And then we carry on making additional changes, and we assume that we're not breaking anything. And that didn't work, right? That's why we started having automated tests, continuous integration, regression testing, et cetera, et cetera, et cetera. We learned about test-driven development, and we learned that, no, every test that you build, every functionality that you add has to be backed by a test. And that test has to be kept forever and run every time you make a change, because otherwise you don't know when you're breaking something. So we learned that lesson. But then when it comes to performance, we still apply the old methodology. We still build the application. We run a big performance round. We hammer it down. We make changes to make sure it works. And then we forget about performance. From that moment on, we assume the application is performant. We carry on making changes and adding things, and we don't test performance again. We just assume that it's still performant. We need to relearn that lesson. We need to understand that performance is just another bit of functionality that A, you need to build gradually, and B, you need to keep testing continuously. So whenever you have your Trello, your Jira, your Kanban board, whatever you're using, performance testing has to be one of the things that you're doing as part of your development process. It needs to be another of your tasks, and it needs to run in small increments. You don't go from 5 to 5,000. You come from 5 to 10 to 50 to 100 to 500 to 1,000, and so on and on. That way, you're not going to think, you're not going to knock things over like you do when you make the big jump, because you're building your performance so slowly that you can notice the things before they become a big problem. And when you do this, you realize that you don't actually need a different performance environment to run your performance tests, because you're not going to be breaking things all over the place. You're building things gradually, and then you have the additional benefit that you are creating a set of tests that you can add to your test suite, which means you can test your performance over and over and over, and you can tell whether some change that you made somewhere is actually breaking the performance. So if you manage to adopt the practice of continuous performance testing, then you do not need a performance environment. Whoops, sorry. To summarize, this is all where I wanted to talk about today. First of all, we learned that the new cloud environments and the new tools that we have, they are fantastic, but they have their own luggage. More environments means more problems. So the ability to create environments easily doesn't come for free. And on those problems, the first one was the management of features, which we can solve with universal feature flags. Then we also have to be mindful about the management of tests, which we can solve with meta automations. And finally, we have to be careful with the proliferation of environments, and it's going to come with the ease of creating environments. And we can tackle that by taking a hard look and rationalizing, arguing very hard on whether we need those arguments or not. This is all I wanted to talk to you today about. I hope you found it useful. I hope it was clear. And if not, this is the time to ask questions. Thank you.
That's fantastic. Thank you so much, Abraham. I'm definitely going to be looking up Corey Quinn. Do you mind, Stephanie, sharing your screen for now?
Sure thing.
That's
Here
great.
we go.
Thanks. As you'll see, there are some questions that have started coming up in the Q&A panel. It would be fantastic if people could vote and add questions there. I know we don't have that much time, but we're going to start off with the question from Marcel. It says, what should the services do if the FAS is down? That's how it's pronounced.
The FAS.
FAS.
I really hope that catches on. I want to see people in meetings saying FAS.
Brilliant.
Right. So Marcel, that's a very good question. This goes in line with the usual, service degradation. What do we do if we need to talk to a service and that service is down or it gives us back an error? So the answer is, whenever you talk to another service, as a general rule, you should try at least to have a backup plan. As in, if I talk to my service and it doesn't come with a reply, what should I do? In this case, probably the safest thing to do is, if when you talk to the service, to the feature flag service, it doesn't give you a response, then assume that the feature is disabled. And the reason for assuming that the feature is disabled is because if you can assume that the feature is enabled, then you probably don't need the feature flag at all. The point of having a feature flag is to enable it on demand. So unless explicitly told, the idea is flags to be disabled. Now, obviously, that wouldn't work for the lower environments where typically you want your flags to be enabled so as to be able to test your new functionality. But then what that will mean is that the tests that you have in those lower environments and that are expecting the functionality for the toggle to be on, those tests will fail, and then you will investigate and you realize that it is because the feature flag service is down.
Great. We probably only have time for one more, but when you talk about chain tests to verify the connection with the third-party components, is this something that can be achieved with contract testing?
Oh, yes, actually, very good point. Yeah, I think contract test is this thing that it kind of came in fashion and then somehow it has disappeared from people's minds, but it's actually a very good tool. They are very difficult to manage and to maintain, and I think that's the reason why, they went out of favor. But yes, I think contract testing is something that can help you here, because on one side, for those of you who are not familiar with contract testing, the idea is you create a contract, and basically you verify both sides of the contract. One contract says, whenever I talk to my third-party service, and I send these calls, I send this information, these are the replies that I get, and that is testing one side of the connection. And then once you do that, then you can say, okay, I know that these are the replies that I get, which means that then in my own integration environment, where I am not including the third parties, I can just substitute the third party with this contract that says, whenever you make this call, this is the answer that I'm going to give you. And I know this is right because I just verified with the actual third party. So that's very interesting, because I presented a number of tools. There was Hoverfly, YMOC, etc. But these would add even more tools to it, like Spring Boot contracts and things like that. There are many different tools for contract testing. So yeah, that's going to expand even more your tool set.
Fantastic. We may get this last one in. So you mentioned a few arguments for which I could dispense of my pre-production environments, but I don't think any of them apply to our team. What can I do next?
Right. Yes, it is possible that none of them apply to your team. However, there's one thing that we always need to be careful with, which is, well, we are humans, and humans have this thing called homeostatic impulses. And the idea is, basically what that means is we are resistive to change. We like keeping things the same, which means that whenever someone comes with a radical idea that says, just get rid of your production environments, your natural response is going to be, no, I can't do that. And your natural response is going to be to try to find arguments for which you cannot make that change. You need to stay as you are. And this means that whenever you have that reaction, you need to be honest with yourself and ask, do I really need this environment, or am I just being resistive to the idea of changing the way I work, right? And you need to be honest with yourself. You need to analyze your situation from outside and then really check whether you do need those environments or not. It might be that after that assessment, you still conclude, yes, I do need these environments. Sorry, I need to keep them. But it is very important that you do that from an honest point of view. You're not just resisting the change, you really conclude that you cannot do it.
Excellent. Thank you. Thank you very much. That was a fantastic talk, and we're very grateful. If you would like to join our next Equal Experts talk, the next one is on Tuesday, March 22nd, and it's You Build It, You Run It. What does it mean to engineers and delivery leads? So this will be from one of our principal consultants, Steve Smith. So we'd love to see you there. And thanks again for joining us, and to Abraham for such a great talk.
Thank you, Kathleen. It was my pleasure.